Hello, this is our Project 2 presentation for Physics 213. My name is Selica Ganeva.
And my name is Miyuki Gerald.
And today we're going to cover radiation and electromagnetic waves. So what is radiation? Radiation is generally a very broad term that explains the emission of energy in the form of electromagnetic waves or as moving subatomic particles, especially high energy particles which are able to cause ionization in other materials. Or in more simple terms, radiation is the energy that moves from one place to another in a form that can be described as either waves or particles. There are generally two types of nuclear radiation. The first one is particle radiation, which it acts in the form of like tiny fast-moving particles that have both energy and mass, and includes alpha particles, beta particles, and neutrons. And electromagnetic radiation, which is waves of pure magnetic and electric energy that have no mass. And examples of the electromagnetic radiation are visible light, X-rays, radio waves, UV light, and other forms of electromagnetic radiation from the electromagnetic spectrum. So how does nuclear radiation form? So essentially every atom on the periodic table has like different forms of like flavors of it called isotopes, which are just atoms of the same element that have the same number of protons, but can have different number of neutrons in them. Usually, every element has like several isotopes of itself, but only one or two of them are stable. So stable atoms don't change over time. That's why they're called stable, while the unstable isotopes have either too many neutrons or too many protons in them. And over time, they'll try to emit the extra energy that they contain to get to a more stable form. And that emission of energy in the form of particles of waves is what we refer to as radiation. So also like the for different types of radiation, the alpha particles are composed of two protons and two neutrons that are emitted from the atom's nucleus. And because they contain no electrons in them, they have an overall charge of +2. Because they are emitted at very high speed and have very large mass, they are very ionizing for different materials. But they are not able to travel over long distances and are able to be stopped only by a few centimeters of air or just by a sheet of paper. While beta particles, on the other hand, are composed of only electrons. However, unlike the electrons that you're more familiar with, like physics and chemistry classes, they're not expelled from the atom's electron shells, but are formed when a neutron inside the atom's nucleus is able to decay into a proton and an electron, where the proton just stays in the nucleus while the electron is just emitted away from it at very high speeds. Because electrons are particles with very, very low masses, they're moderately ionizing for different materials, but have very high penetration rates and are able to be stopped by several meters of air or like thin aluminum sheets. Neutrons are essentially when an atom has too many neutrons in its nucleus, and over time it's able to emit them at a constant rate. And gamma rays are waves of electromagnetic radiation that are just like a form of pure energy that has no mass and are often emitted after alpha and beta radiation. Because they have no mass, they have very, very high penetration rate and are able to travel over very long distances. But because they're only weakly ionizing and are able to be stopped either by several meters of lead or or like blocks of concrete.
Taking a slight turn in our thinking of radiation, we can look at the other side of it. Electromagnetic radiation that is characterized by wave-like behavior. As mentioned in our brief overview of the two types, instead of focusing on the emission of particles, like mentioned in previous slides, electromagnetic radiation focuses on massless particles, specifically photons. From Physics 213, we know particles can create an electric field. And if that particle is accelerated, it can create a magnetic field around it. This causes an interaction between the electric field and the magnetic field that is called the electromagnetic field. As a particle creates these fields, they move outwards, propagating at the speed of light. And this propagation creates what we call electromagnetic waves. We can visualize this with the images on the left. Beginning with the upper one, we can note that the two fields are at a 90-degree angle from each other, with, in this specific image, electric field colored blue and magnetic field colored red. And together, we see them propagate outwards. The lower image shows a particle, the visible red dot, with an electric field moving to the right in space that creates a magnetic field. Both of these fields affect each other, and we can slowly see them propagating outwards in the colors blue and red. These waves can then be connected to light. Similar to what we learned in Physics 212, light, or electromagnetic radiation, can be considered to be waves. As the name electromagnetic radiation suggests, these waves are the same waves mentioned in the previous slide. As the particle creates electric and magnetic fields that interact to create an electromagnetic field, they create the electromagnetic waves, which give us light. That light includes the visible light we can see or the light we can't see, like UV and radio. Depending on how a particle travels, we get different frequencies and energies that give us these different waves. A longer wavelength from a slower particle acceleration gives us low energy, while a faster acceleration gives us shorter waves and higher energy. And all of this easily connects to what we've covered in Physics 213. We started Physics 213 learning about electricity and later covered magnetism and then the connection between the two. Some specific examples are electric fields and magnetic fields from class, which I previously discussed how the interaction between the two gives us an electromagnetic field, which is another topic we slightly covered in class, and electromagnetic waves. Coulomb's law and force explain charge interactions, such as attraction and repelling, which affect how particle radiation is able to affect the atoms of other materials. Lastly, Faraday's law also applies to radiation by helping explain the connection of magnetic flux and electric field, the equation which can be seen in the upper right corner. I'd also like to note that this can also be connected back to Physics 212 with topics such as light and wave-particle duality. Now, connecting this even more to class, in Physics 213, we did some specific examples in Studio and through practice quiz that reflect with what we've covered today about radiation. We have 3 examples here that come from Studio Week 1, Week 9, and also the practice quiz from the final, or for the final. The practice example from Studio Week 1 covers electric fields, specifically understanding the variation of them. It shows how electric fields can have different sizes and shapes and are different depending where you are located in them. This connects to our topic through understanding electric fields, which directly contribute to electromagnetism and radiation. The example from Studio Week 9 covers magnetic fields and flux. In this example, we have a magnetic field and are shown a moving wire loop. One of the questions from the example asks if there is an induced current, which we find that there actually is in certain parts of this magnetic field. This goes to show one of the ways magnetic fields and electric fields are connected and can interact with each other, which is a really important idea in electromagnetism.
The third example we did from class system material we covered today is from practice quiz 8B, where the practice quiz activity explores how the magnetic field created by the moving charges on the screen is able to affect the magnetic force they experience. This connects to the topic we got about alpha and beta radiation, which are also made up of moving particles with their own charge and velocity, and hence they're also able to produce their own electric and magnetic field around them. Due to the electric and the action of the electric and magnetic field is also able to create an electric and magnetic force, which they're also able to carry with them. And it is because of this electric and magnetic force that they carry, alpha and beta particles are able, when they travel and encounter atoms of different materials, the force that they carry is able to knock off the electrons of the atoms they meet, and thus causing them to become positive ions. And this is what causes the ionization that can be experienced when very high energy radiation meets different materials. Those are the references that we used. And thank you very much for your attention.